Teach me about the Great Lakes. Teach me about the Great Lakes. Welcome back to Teach Me About the Great Lakes, a twice monthly podcast in which I, a Great Lakes novice, ask people who are smarter and harder working than I am. There it is. To teach me all about the Great Lakes. My name is Stuart Carlton, and I know a lot about doing introductions to podcasts, but I don't know a lot about the Great Lakes, and so we're here to learn. I cannot even believe this is happening. This is a lovely day, people. Some days are special, but some days are more special than others. I'm joined today by the man, the myth, the legend. It's Hope Charters. Hope, how are you?
I am a woman, not a man. Yes, I am here.
It doesn't flow as well. You're right. The woman, the myth. The legend, Hope Charters. What's up, Hope?
I'm doing well. I'm excited to be back. It's been a long time.
I think this is the first time you've been on a show with me this year. You were on the Freedom Seekers one, the great episode we did on the Underground Railroad curriculum, which I will link to in the show notes. But I don't think we have podcastily hung out in a bit.
Yeah, it's the pandemic has been pretty rough. I haven't felt like being on a podcast. Not gonna lie.
Well, neither have I. But here I am every other week. No, this is great. Actually, this has been the proverbial port in a storm. This has been the cherry on top of the bleep Sunday that is 2020, and you just seek out the cherry. Anyway, really, not much has changed since you left, except for one important thing, and that thing is we are preparing for the Lakeys. I don't know. Do you know about the Lakeys?
No, please tell me about the Lakeys. I feel like I've heard about them, but I don't know exactly what you're planning.
Well, I don't know that either. I just know we're having Lakeys. All right, this is the thing, is we're having Lakeys. And what the Lakeys are, they are our award show. They are probably not the least prestigious Great Lakes-related award show that there is. And so this is going to be probably our last show of the year, unless, like the book club episode, we just keep delaying it for various reasons, in which case the Lakeys will happen. Who knows? But no, these are happening in December. This is going to be our year wrap-up. This is the first annual Lakeys. We're going to have a bunch of people on there, but what we need you, listener, right now. Pause this. Well, don't pause it yet because you haven't heard what to do. After I tell you what to do, then you're going to pause it and go to bit.ly.com/Lakeys21. That's LAKIES 21. And you need to nominate some stuff for the Lakeys. We have a lot of categories. We have the Science Communication of the Year. We have like the Outreach Program of the Year, the Great Lakes News of the Year, the Great Lakes Science Podcast of the Year, non-teaching about the Great Lakes edition, the General Podcast. I think Podcast of the Year might be, there's a ton of categories. Great Lakes Animal of the Year. And the one I want to talk about today, which is Great Lakes Non-Animal of the Year. So we have a nominee for Great Lakes Non-Animal of the Year. And that nominee is the oyster mushroom. It's a nominee. Have you had an oyster mushroom, Hope?
I have not. Also, though, when you're sending people to URLs, you should probably get the URL right. It's not bit.ly.com. It's bit.ly/whatever the end is.
Yeah, another thing is when you're correcting your supervisor, you should make sure that your correction is accurate.
Did you actually get a bit.ly.com? That's weird.
Yeah, just go ahead and paste that into your browser right now. Right now. Just paste
all right. I'm going to try
go
it.
Go ahead and paste that in. All right, hold on. All right, bit.ly.com.
Holy cow, he knows what he's doing.
Oh, my goodness.
There you go, Stuart.
This is why I've missed having you on.
I'm a train wreck.
No, it's good. It's all good stuff. So, or you can go to bit.ly/Lakeys21. That's fine. So, do you know about oyster mushrooms, Hope?
No, I do not know about these mushrooms. Wait, are they oysters or are they mushrooms?
No, they're mushrooms. That's a good question, right? It would be mushroom oysters otherwise.
Either way, they sound disgusting because I like neither oysters nor mushrooms. I'm not going to lie. So.
Oh, the nominee, well, I'm going to tell you what the nomination says here. Oyster mushrooms, which are not aquatic, as we both knew, obviously, but they're native to the region. And this is a direct quote from the nomination. Totally delicious. Totally delicious. And then on top of that, this is actually really interesting. They have a lot of promise in terms of the bioremediation of pollutants. So that's cool. You can use mushrooms, and it's called mycoremediation. I'll put some links to it. Myca remediation. I can't remember. Anyway, you can use mushrooms to try to pull some pollutants out of the ground. So that is really cool. And that is why they were nominated for a Lakey, is because, you know, they're tasty. They're local, and you can use them to remediate pollutants. And so, you know, that's an important thing.
Wait, so it sounds to me like you use mushrooms to pull pollutants out of the ground, but then you're also saying that you can eat them. So why would you want to eat the pollutants? No,
you don't. I don't know a ton about mushroom bioremediation, but no, you don't eat those. So you grow a whole separate one. Don't look up where mushrooms are grown, though. Just don't do that, like the white button mushrooms. But if you don't like them, it'll be fine. Anyway, and then some species, I also found out, some species even glow in the dark, which I did not know. So I'm gonna not gonna lie, animal of the year and non-animal of the year are some of our most contentious categories.
Wait, so what's up in the ranks for animal of the year?
We just have to tune into Lakeys to find out. I'm not going to tell you that.
I'm so sorry. Okay.
But that's a great question, Hope, and I'm glad you asked that. And the answer is the oyster mushrooms are a great non-animal, but will they win the Lakey? Tune in to find out. And if you're not a big oyster mushroom fan, like, some of the people on this very episode, then nominate your own Lakey. Go to bit.ly.com/Lakeys21 and do it. Just do it. Or bit.ly/Lakeys21. We don't even care. We believe in URL diversity. So do that. Pretty excited about our interview today. Her name is Dr. Kelly Robinson. She's an assistant professor at the Quantitative Fisheries Center in the Department of Fisheries and Wildlife at Michigan State. And she does a lot of work on decision analysis or structured decision making. And I kind of know what that is. And I kind of know that it's important. But, I also know that we need to learn more about it, or at least I do. So there's a lot for me to learn. So let's go ahead and bring on Kelly. And so we'll just talk about your work kind of generally and what goes into it and what we've learned from it and just, anything else. I just found out you did a submersible, so we'll probably talk about that too, because that, I don't know, from the outside, I don't know that you'll ever do anything cooler than that again in your career.
Oh, no, I definitely won't. I peaked in grad school for sure.
Yeah, I hear you there. Okay, good. So yeah, actually, why don't we tell me about the submersible? So you were like a marine scientist, right, in grad school, and how does that end up with you in a submersible? Because I went to graduate school and studied some marine stuff, but I did not end up in a submersible. So I was doing it wrong. What did I do wrong, I guess?
I don't know. I think I really lucked out with my advisor that I was working with. So I was in grad school at the College of Charleston in the marine biology program, getting my master's. And my study organism was the barrelfish, which is a fish that's found in deep waters around the area called the Charleston Bump, which is about 100 miles offshore from South Carolina. And we really didn't know much about it. We would start catching them when they're, 5 years old or older. So there's a lot of hypotheses about, what's going on with the younger age classes of these fish. I mean, to cut to the chase, we still don't really know. I didn't learn that from the submersible, but my advisor was George Sudbury, who was a scientist at the South Carolina Department of Natural Resources, and he had been doing some work with the NOAA Ocean Exploration Program, and it was a really cool program. I think it's still ongoing. Certainly, all of the stuff is still online for it, where it's kind of allows marine scientists to go out and do research exploring the ocean, but we do it in such a way that it can be useful for like K-12 teachers to teach about different aspects of the ocean or fish or whatever we're working on. So the one that we were working on was called The Estuary to the Abyss. So we did transects from kind of shallower waters all the way to the area around the Charleston Bump that George had been studying for a number of years, looking at how it affects fish that are important for fisheries, like some of these lesser known things like barrelfish, but also other more important fishes that we tend to catch. So as part of that, we did 2 submersible dives a day. I got to do one of those dives. I think it was about a 10-day cruise. Just myself and some other grad students, some other folks that worked at South Carolina DNR. We did submersible dives. We did other sorts of sampling, all of which I can't remember now because that was quite a long time ago. And we wrote up little, blurbs about the stuff we were doing to post on that ocean exploration website so that teachers could use that for teaching.
For those of us who maybe don't know what a submersible is, can you explain what it is?
Yeah, I can back up. The submersible, the one that we were on was the Johnson Sea Link, which is housed on the RV Stuart Johnson, which is, if you've ever seen a picture of it looks like a submarine, but it's got a giant glass bubble on the front of it. It's used for a lot of different types of underwater research, obviously. And you can see in the front of it, there's someone who's driving it in this bubble, and there's a scientist sitting next to them. But little did you know, there's also 2 people that sit in the back of this thing with a porthole that's the size of about a dinner plate. That's where I was.
Wait, I'm looking at this thing now. No, this That's how big. Oh, I'm going to put this link in the show notes. I'll paste it in the little chat thing, Hope.
Sure,
You
yeah.
were in that?
Yeah, and
Underwater?
I was in the back of it. So
It has a back? It
it
looks
has
like
a
it's
back.
just all one thing.
I can look at the picture with you, but yeah, it's so the front of it, yeah, is where the scientist and the driver sits. And if you were to look at the back of it, you would see that there's room for two more people. There's another person who helps with running the submersible, and then another scientist back there. Yeah, so you're looking at a porthole, but I mean, it's like the coolest porthole that you've ever looked at. So we went down 1,000 meters or 3,000 feet to, basically kind of see what was going on the ocean floor. And I can try to find some links to what we were doing too, so I can send it to you. But yeah, it was really neat. We turn off all the lights so you could see the bioluminescence on the way down, and then we got to see some Barrett's species of fish and lots of different kinds of cool invertebrates and things that you've never seen before. You can also use that submersible to take samples of things on the ocean floor. So we have brought in some really cool sea creatures to document and archive and use for different projects. So it's just a really neat experience. I mean, I was in the back, so it wasn't quite as amazing as that 360-degree bubble, but it still was, as you said at the beginning, the coolest thing I'll ever get to do in science.
Yeah, on a day literally where William Shatner is about to get launched into space.
Right.
It's a good reminder that we have so much to do kind of at home too in terms of exploration. This is
for sure.
Yeah, this is cool.
So you do not want to go in a submersible. I'm looking at a picture of it right now. You do not want to go if you have any kind of claustrophobia. I'm assuming.
No, you don't. I was concerned because I do have a tendency to get motion sickness, and I've heard stories that when you're trying to retrieve the thing, if the water is too rough, you kind of basically have to bob around in the water until it calms down so they can get you back out of the water. So they're very, cautious about launching the thing if they expect that the weather is going to change at all. But and you kind of have to. Didn't drink any water for a while beforehand. So
I hope you did not puke on the other 3 people that were sitting.
No, I did not. There was concern, but I was totally fine. But I think it was probably about 3 or 4 hours that it took to get down there and come back up. So
is it a barometric pressure thing too? Now that I think about it, like, do you have to come up slowly like divers do, or can you just shoot up and you're good?
I want to say yeah, probably, but honestly, it's been a while, so I can't remember exactly how long it took us to come back up. It wasn't, we weren't shooting up from the bottom for sure. But
yeah. Sure.
Yeah.
So let's take it back a little bit though. But as soon as I saw submersible, I'm like, well, we got to start there.
Mm-hmm.
So how did you get into like fish stuff? Like, what was the attraction of that to you? Coming up.
Yeah. So I grew up in coastal Virginia, around the Virginia Beach area, in a city called Chesapeake. So I just kind of grew up around the ocean and really loved going to the local marine science museum. Even when I started grad school, though, I wasn't quite sure whether it was going to be fisheries or some other aspect of marine biology that I was interested in. But I lucked out again, found a good project working on this fish, the barrelfish. And it kind of, hooked me in terms of working on fisheries and then thinking about how we can better manage some of these fisheries. So the research I was doing, like I mentioned, was just trying to understand kind of how old this fish gets. We found that it lives up to about 85 years and it has a really high age at maturity. So we knew that it's difficult to manage because it could be overfished pretty easily. And that kind of got me interested in thinking about how we manage fish in general.
So the management connection was kind of there for you right away.
Yeah, working directly with the Department of Natural Resources, there was a kind of management interest for a lot of the research that's done there.
Yeah, that's kind of what was with me. So like I started working on the project with so Kelly and I share an advisor. My master's advisor was her PhD advisor. Is that right?
Yep. Mm-hmm.
Yeah, and so we were working on a project with a imperiled species of sucker, and yeah, we worked with South Carolina DNR also. Actually, now that I think about it, and some other people, and that management was built right in because to me that's a lot of the so what in addition to the what, right?
Yeah, exactly.
And then, so then you went to UGA, and you sort of, is that when you moved at UGA? When did you move into freshwater side? Was that at UGA or was that later?
That was later. So UGA, I did move kind of inland a little bit. I was working in estuarine systems there. So yeah, that was with Cecil Jennings, who is recently retired, but was the head of the Georgia co-op unit there. And that project was looking at impounded wetlands that are managed for waterfowl and shorebirds. So these are wetlands that actually had been impounded since, I want to say, maybe the 16 or 1700s for rice cultivation. And then they used the same technology they had back then, which obviously wasn't great technology, but it was this idea of having these trunks that move water in and out based on the tidal cycles, and they could move the water in and out to grow food for these birds. So we were looking at the fish within these structures and found that basically, they drain them into canals during the summer. The water gets pretty low in oxygen. The fish basically die over the summer. So that was kind of the disappointing part of the project, was finding how many fish die in these structures. But it did, again, kind of lend itself to thinking about management. How can we manage these things for more than one objective? Can we manage them to still, promote the food for the birds that use them as they're either migratory birds or shorebirds, and then can we also think about better ways to manage them for the fish? A lot of these fish are things like young of the year, tarpon or spot or croaker that move into the estuary as larvae and then move out after their first year. So it was really an interesting project. There was a lot of time spent trying to figure out how to even sample the fish in these things, but we finally figured it out. And yeah, so it was fun. It's a beautiful area to work in as well.
Was the sampling challenge, was that because of like depth and there was just a bunch of junk in the way, like trees or whatever, or was it? Yeah.
It was more, so these things are pretty clear. They're small canals that we're sampling, but they were too saline to really do a good job with a shocker. They're very difficult to kind of get larger vessels into as well. Some of these, canals will maybe be like 10 feet wide. And so then we tried gill nets and things like that, but we're just not capturing the small fish. So we did end up using some rotenone to sample these things. We sampled, small sections with rotenone and then neutralized it afterwards. But
rotenoning with Cecil. Oh my goodness. He had this one project. What was the big lake? It has a different name in Georgia
Clark's
and
Hill.
South Carolina.
Yes, I got to work on that too.
And, yep. And so they got just kind of a standing contract with the DNRs or whatever. They would rotenone these different coves. So what rotenone is, maybe Kelly, you can fill me on details, but essentially what it is it some sort of chemical that I think makes it so fish can no longer get oxygen from the water.
Right. Yeah.
Through the use of the power of chemistry. And so what you do is you tent off, or you net off a cove in a lake is what we were doing. And you put some sort of antidote chemical, I think, on the other side of the net. And then you put the rotenone in the cove. And on the first day, like a bunch of fish will die and float up to the top, and that's all fine. And you get them, and it's all bluegill, and you just have to figure out what kind of bluegill, or it's all sunfish. And you write down, Leopomis species, or if you're really good, you can identify them. But nobody actually can. Kelly probably could. Anyway,
no, I don't know
and then the problem is the first day's all fine, but then there's a second day. And the fish that were slower to float up or floated up overnight, and they develop a certain stench, I think.
That's a good word.
And then there's a third day. And the third day is the day for the undergraduate technicians and not the graduate students, because by the third day, things are bleak.
They're pretty ripe, yeah.
Is this ethical?
Is this ethical?
Yeah, it just sounds so mean. You're just, like, in order to get your sample, you're just killing off a ton of them.
I know. So the whole goal with any of that sampling is really to get a handle on what's going on with the entire fish community. And these coves are not super large. I mean, these are huge reservoirs we were working in Georgia. It's on the border of Georgia and South Carolina. I want to say that lake, someone told me one time that it had more coastline than the coast of California. So it's quite a large system. And so it's a small, area that you're trying to just get a handle on what's going on with the entire fish community. It's not used that often, but sometimes it's the thing you have that you can use to get a sense of what's going on. Luckily, with my project in the impounded wetlands, luckily, I guess, we had so many alligators and birds around that we couldn't do a second day pickup because they would just mow through everything overnight. So yeah, there was no need to pick up anything dead the next day. Somebody else had already eaten it.
At least they were being used. Yeah.
Exactly.
No, it's a good question. Open is always worth thinking about, right? But you can't go into fish biology without getting comfortable with the fact that over the course of your life, you will kill.
Yeah, you do have to kill some fish to get a handle of what's going on. I felt a little better with my own project that knowing that these fish likely weren't going to make it through the summer anyway. So I was sparing them that death, I guess.
And so then, but so all right. So I could reminisce about my days road noting coves for hours, and but I think that that's not the purpose that we're here. And so then you moved on to the Great Lakes, where you are now, right? How did that? Was that just because there was a job at Michigan State and you being awesome got that, or was there did you want to move into this area?
Probably so. Yes, I think that is a really great opportunity for me in terms of the fit. So in between, getting my PhD and coming here, I actually did a postdoc at Cornell in the New York co-op unit, but had nothing to do with fish. So I did a lot of structured decision making work for things like turkey and deer harvest management and thinking about endangered birds and stuff like that, which was really cool. But then coming off of that and trying to find a position in fisheries, I feel like a lot of times people look at my CV and say, well, she's been working on deer. Why is she applying for this job as a fisheries scientist? But I work now in the Quantitative Fisheries Center, which is part of the Department of Fisheries and Wildlife at MSU. And part of our goal is helping agencies around the Great Lakes to, with their quantitative needs and to help them make decisions using things like decision analysis. So they recognized what I'd been doing and why, I still would be a good fit, even though I had spent a couple of years thinking about deer population dynamics rather than the population dynamics of fish. So I think it was just a really great fit to work here, coming off of those other experiences in my education.
Help us understand what decision analysis is and how you use that. And, yeah.
So you'll kind of hear me say interchangeably decision analysis or structured decision making, but the goal with all of that is to help decision makers to walk through a series of steps to more transparently come to a decision. And so the way we do that is helping them to first kind of think about what the actual problem is. What is the decision that needs to be made? All the aspects that you might not consider when you start to think about a decision, like who are the stakeholders, who are the actual decision makers, what's the spatial scale of this decision, how often is this decision going to be made, all of these things that people don't often articulate when they need to make a management decision, and then it comes back to haunt them later because they realize they weren't all on the same page about what the decision was they were trying to make in the first place. And then we ask them to say, what are your values? What are the things that you want to achieve? What are these objectives that we would say, if they're achieved, would solve the problem? And then we finally get to the point where we say, what are the actions that we could take to solve those objectives, to achieve those objectives? So we call it values-based because we're not jumping straight to the decision points, not jumping straight to the actions. Then we spend a lot of time thinking about the modeling. So how can we predict how each action we could evaluate would help us to achieve those objectives? So lots of quantitative modeling, working with experts, digging into different data sources, lots of different ways to think about just predicting how these different actions could achieve our objectives or not. Then we get to the trade-offs where we find that often there's not one action that best achieves everything everyone wants. So then how do we make those trade-offs based on what we now know could happen with these different actions? The whole goal is really just to break the decision down, to work through the pieces of it rather than trying to think about it all. When it's more difficult when you're just thinking about it all at one time rather than in small chunks, where you can kind of be a little more deliberate about it.
Can you give like a real life example of one of the decisions you've helped people make in the Great Lakes?
Yeah, sure. So the one that I've been thinking about a little recently, it revolves around invasive Asian carps. So you've seen the videos maybe of the silver carp knocking people out of their boats into the lakes and things like that. So the one species that we actually have in the Great Lakes right now is grass carp, which is not knocking people out of their boats, but is still a concern because it consumes the vegetation that other fish and birds and things like that might use during their life cycle. So grass carp are reproducing now in Lake Erie, and there's a lot of concern about, well, how do we respond to this fish and at least control the numbers, if not eradicate it. So we worked with groups around Lake Erie, all the different agencies and researchers that have been thinking about this problem, to walk through that same series of steps. So we defined the problem in terms of it being Lake Erie. The decision makers are all the agencies that have decision-making authority on Lake Erie. We identified objectives related to like ecological things like containing the population from growing or from moving into the other lakes. We had economic objective that was mostly not spending all the money in the world to do it. They wanted to have the money to do it, but we also recognized that any money spent in a management agency on one thing is not available for something else. And then we had objectives related to things like collateral damage from the actions you could take. So you might like spread some sort of pesticide like rotenone to kill that fish, but then you'd be damaging other parts of the ecosystem, like removing fish that you might want to have there. So thinking about that in terms of, threatened and endangered species, in terms of stakeholder needs, like fishers who might be affected by the things that we could do. All those kinds of things came into the objectives. And so in this case, we evaluated some scenarios because one thing we found is that we weren't really sure. We had tons of ideas about things to do, but because it's an invasive species, nobody really knew exactly how these things might work out. It's a new ecosystem that this fish is coming into. So we spent some time trying to understand kind of how effective do we need to be to achieve our goals. And so that's kind of where we landed at the end. So we said we need to know more about how effective our gear are. Is it doing the job that it needs to do, or do we need to come up with something else? So now we're kind of doing some gear evaluation surveys and trying to understand how effective we can be. That's kind of one of the examples there.
I mean, so this just sounds like you get a ton of people in the room, right? And I can tell you came from Cornell now that I think about it, because it sounds like classic stuff with like Decker and in the Human Dimensions lab.
Oh,
right?
yeah, definitely. Yeah. I worked with Dan on some of that stuff and there.
So it's a bunch of people in a room in a lot of meetings, it sounds like, right? And I imagine you would never admit to this, of course, but I imagine there are occasionally excruciating meetings. How do you, which is my words, not yours, but how do you decide who even to bring into the room for that kind of stuff? Like, it seems like you could have the whole universe there, right?
You could. And that's a really good question. I think it's something that we're still kind of, in some ways, struggling with in the decision analysis for natural resources world. So the grass carp project, the people that we brought into the room were managers and biologists that worked for either a state or federal agency or provincial agency on the Canadian side, or that were, university researchers. So that one was a little bit more constrained in terms of, we still had a lot of people there, but, largely professionals in the management world. But I think, when we started to try to think about some of these other decisions related to, harvesting fish or things that are more, that would be more important or more interesting to anglers or other stakeholders, trying to think about how you choose the people in the room, I think really can influence the decision that comes out of it, right? And so I think there's a lot of work still being done on trying to think more about the social science side of decision making and how to integrate that social science into the ecological science that we kind of have a handle on. We may not know what's going on with the particular fish species, but we know how to create models. We know how to make predictions and evaluate those uncertainties. But working with more of the stakeholders and rights holders in the Great Lakes, we have a lot of different indigenous groups that have rights towards some of these different or towards our fisheries and wildlife resources. So trying to bring all those different viewpoints in the room is difficult and not perfect.
But it's also like a real balance, right? Like I can see an ethics case for a lot of like thinking about just ethically who should be involved, but also, at some point, you got to balance breadth and depth with actually getting stuff done too.
You do, and it does come down to trying to build trust with people too, both for us as the facilitators and then among each other. So that's what it reminds me a lot of. We do a lot of work in AOC's areas of concern, and we think about that with the diverse stakeholder groups there and the work that's being done, and a lot of it's angler focused because that's a real notable user group, right? But thinking about building trust in other groups as well, or how do you measure trust? It's hard. Actually, a guy, Mark Stern in your hometown or home state of Virginia, he's at Virginia Tech now. He does interesting work on trust in natural resource management. I have to check that out.
Yeah. Anyway, your work makes me think of that and the different types of trust and how that can be evaluated and things like that. And so we do SDM, as I call it, SDM, and so with the grass carp, what are other like systems systems? What is the right word? Cases, model, places where you apply that, whatever.
Sure. Any of that is fine.
Okay.
So I will say that coming into working at the Quantitative Fisheries Center or the QFC, was great because the Great Lakes region has already been primed from my predecessor, Mike Jones, who just retired, who's been working on these kinds of same structured decision making or decision analytic issues with people around the Great Lakes for years. So it's a really great system to work in because they kind of want this kind of help with making decisions. And so, we've got problems where we're working on stocking salmonids in Lake Michigan or a little bit in Lake Huron. We're thinking about what are some of the other ones? I've got a new project that I've just started where we're trying to understand how we can make Michigan's cold water streams more resilient to the changing ecosystem. So specifically, not only climate change, but largely focused on climate change and like land use change. And so we're starting to work with different stakeholders around the Au Sable River and Michigan on trying, as a first case study, how can we think about ways to make the fishery and, with it, the whole ecosystem more resilient to climate change. I've been thinking about things like walleye harvest. We've been working with Ontario Ministry of Natural Resources and different rights and user groups up there to think about how best to harvest walleye and change their walleye harvest management plan that's been in place for like 20 years and needs some revisions. So working with the kind of fishery management zone councils and First Nations groups and Métis Nations groups to try to get at their goals and objectives and use that towards making a new management plan. So there's a couple of examples anyway of things that we've got going on.
It feels like structured decision making can be applied to so many different things. So how do you decide, because you're all about decisions, how do you decide what decisions actually need this kind of framework?
I think one of the biggest things it gets back a little bit to that trust thing and just whether a group is. So I have this great graph that I teach this class in structured decision making for graduate students, and I didn't make the graph, but one of my colleagues did, and it kind of shows like when you're in the realm of structured decision making. But if you can't get a group to even agree kind of on what the objectives are or what the science is telling you, then you may be outside the bounds of STM. You may be more in kind of like conflict resolution or they call it like joint fact finding, which I've never done, but I think just there's a realm in which you've got tangible objectives you can work towards achieving, and you will agree that this is at least the data that are available. Then you can. It's useful to do that process. But
so in this modern age, it seems like the structured decision making is becoming harder and harder, since agreeing on facts seems to be something we do less and less.
Yeah, that's true.
So this is a cool tool. Like, so if people want to go and find out more about structured decision making, is this the kind of thing where there is like a popular book on it, or is it you got to go to the literature and?
So there is a really nice book, and I think it's actually called Structured Decision Making. There's a group in British Columbia that wrote a book that it's still like towards science and natural resources decision making, but it's still kind of accessible. There's also a book by Hammond from 1999. I think it's called Making Hard Choices or something like that, and it talks about things like making decisions for buying a house, or how you could use the tenets of decision analysis for life choices, which I'm not great at doing.
There we go. Yep. So here's Structured Decision Making, Practical Guide to Environmental Management Choices.
Yeah. So that one's more if you're interested in it for natural resources decision making. It's a good first choice.
And we'll put a link to that in our show notes. And we'll put also a link to, what is it called? Making Hard Choices.
I think that's the name of it.
I'm going to write one called Punting on Hard Choices, a way to hit middle age and be vaguely dissatisfied. It'll be good. Bestseller. But, good. Well, we'll put links to those in our show notes, which you can find at teachmeaboutthegreatlakes.com/43, because this is episode 43, believe it or not.
So I just looked it up. That is actually called Smart Choices, not Making Hard Choices. Smart Choices.
You see, to me, those are easy choices then.
Right.
Okay. Yeah.
So that's the one that's quite useful.
Well, Kelly, this is really interesting stuff, and it sounds like a really powerful tool that I'm excited to see how it develops over time. But that's actually not why we invited you here on Teach Me About the Great Lakes this week.
Huh.
No, it's not. It's not. The reason we invite you on Teach Me About the Great Lakes is to ask two questions. The first of which is this. If you could choose to have a great donut for breakfast or a great sandwich for lunch, which would you choose?
So it's an easy answer. I would say the sandwich for sure, but my husband, who is across the hall from me right now, would be appalled that I would choose a sandwich over a donut. So yeah.
Okay. All right. Sandwich. So you were at Michigan State. Does that mean you're in East Lansing? Are you in East
I
Lansing?
am. Yeah.
All right. So when I go to visit, I'm going to visit all-star guest Brian Roth, who's going to teach me about the Great Lakes Hall of Fame. And then when I'm done talking with Brian, and he wants a cheesesteak. He's all about the cheesesteak sandwich, he said. And he has strong opinions on cheesesteaks. So I've had a cheesesteak sandwich. We wrote Nona Cove, pick up a bunch of dead fish, have a cheesesteak, wake up the next day, more dead fish, and I want another lunch because nothing like Rotenone to make you want lunch. Where should I go to get a really great sandwich in East Lansing?
In East Lansing. There are, I would say, more than one good option for a good sandwich, but I do like Jersey Giant. It's a kind of a local chain. Tons of they have giant sandwiches that are quite good, and you can customize them any way you want.
I love that you just put like 3 feet in between your two hands.
Yes, I can eat half of one, and I'm too full. So yeah.
All right, I will go in and I'll order the titular giant. Fantastic. And then the second question is this. So you've been in the Great Lakes now for a number of years, not as many as you will be, hopefully, for our sake, since you're doing such great work. Is there like a special place in the Great Lakes that you'd like to share with our audience? And if so, what makes it special to you?
Yeah, so that's a really good question because I've been here 5 years, and I would say that I haven't visited as much of the Great Lakes as one should. So in some ways, I feel like your listeners may be able to provide me with more options. But I was thinking about that. One of the
assistant prof life.
Right, I know, yeah. So, but I think, I was trying to think about this. Good Harbor Beach on Lake Michigan, I think is probably one of my favorite places. It's we used to have we have a friend that used to live in Traverse City, and she would take us there to go to the beach. And it was my first time swimming in the Great Lakes, which was quite cold and not what I was used to. But it's a really beautiful area. There's not a lot of people on the beach. Can look for Petoskey stones, find lots of Petoskey stones.
Wait, what's a Petoskey stone? I don't know what a Petoskey stone is.
Isn't it the one where they have like the weird little like circles of different colors?
They do. Them? Yeah, so Petoskey stones are unique to the kind of the northern lower peninsula of Michigan. There's actually a town called Petoskey, but they are coral that from back when there was salt water.
These are cool.
Yeah. So, and when you pick them up, you can see them better when they're wet. It's kind of hard to see all of the you can see all the pieces how it looks like coral after it has. So it's fossil coral from the Great Lakes. So it's super exciting when you find one on the beach. Being a nerd about all things biology, but
and it's the state stone of Michigan. Look at that. Look at that. All right.
When I visited one of our old employees, Jay, who moved out to is it Bois Blanc Island in Michigan?
Something like that. Yeah.
Yeah. We picked up Petoskey stones and pudding stones. So if you find pudding stones, they're also very fun.
All right. What's a pudding stone? Look at this. I'm learning so much about stones. Anytime I talk to Hope, I'm learning about stones.
I think they have like little red dots on them.
Oh, okay.
Pudding?
Yeah, just spelled like pudding that you eat. But they have little red pieces.
Oh, neat. I'll have to check for those next time too.
Great. Well, I've learned so much. Is there a place you want to send people to find out more about your work? Do you do a social media or is there a website?
So we do. The QFC has a website. You can Google us, Quantitative Fisheries Center, Michigan State University. I have a Twitter handle. If occasionally I tweet things about science. It's at K. Robinson.
Great. Well, Dr. Kelly Robinson, Assistant Professor at the Quantitative Fisheries Center in the Department of Fisheries and Wildlife, in Michigan State University. Thank you so much for coming on and teaching us all about the Great Lakes.
Yeah, thanks for having me. It was fun.
All right, structured decision-making, Hope. That's pretty important stuff, right?
Oh, yeah, definitely. I make structured decisions every day of my life.
Well,
actually, completely
that's
unstructured.
the main difference. I was going to say, wait a minute. Holy hell. What am I doing wrong? If that's structured decision-making, what am I doing? Yeah, although what's really cool about it is it seems like she's working on, you can apply it to all these big issues, kind of like you were saying, right? I mean, if you look, she's looking at lamprey, she's looking at carp, she's looking at, salmonid stocking, which are, the trouts and things like that. So if you've read Death and Life of the Great, basically she went chapter by chapter through death and life, all these big issues, and is sort of working on those. So that's big, important work.
Yeah, it almost sounds like they need somebody like her in every agency working in the Great Lakes possible. So I'm surprised I've heard of structured decision making.
Yeah, it's a way of doing it for. I mean, the problem is, well, agencies, it's hard to get agencies to move, right? Because they have mandates and things like that. And then it's an expensive, time-consuming process as part of it. I mean, not that expensive. It's expensive in terms of time and having all these meetings and things like that. And that's kind of a error. But I agree. I think hopefully you'll see a lot more of that and formally modeling decisions and all that stuff. And we'll see. Yeah. So I was thinking with the road gnomes and the electrofishing, we talked about that. Have you gone electrofishing? Is that something you've done? I remember you had waders, right?
I do have waders. I have not been electrofishing.
Oh.
But electrofishing, they don't die, right? So you're just like kind of shocking them, incapacitating them, and then getting your sample and putting them back.
That is generally true, but the little ones, not gonna lie, the little ones. It's just carnage out there.
I hate
so there's two types. It depends on what one. Like the boat electroshocker, and I don't know the physics behind this, so people can email us at teachmeaboutthegreatlakes@gmail.com, and I'll include your. I'll respond to your email in the next episode, maybe. But the boat electroshockers, like I think they have a little more oomph than the backpack ones, and so you ride on a boat, and that's where we were trying to get like the big red horse suckers, and you'll see just trails of fish that we'll assume, revive kind of later. But the problem with the backpack ones is you're in the water, and I swear to frickin' God, two things. One, my waders always have hole in them, which means that you're getting a little bit of water in your wader, and also just a little of electricity. but the worst thing is I'm such a moron that like if I don't have you can get gloves, but you don't always have the gloves, and so you want to keep your hands like out of the water, right? But I'll see a fish that we're looking for, like a target species, swimming by, and so I'll have one hand, I'll let go of the electroshocker, and I'll grab this has happened every time I go electrofishing. And so you grab the fish, and you're like, or maybe I remember to put mine, but I forget that I'm with a whole group of people, all carrying one of these Smith Root backpack shockers. So I have grabbed electrofishing water like dozens of times. And I'm just horrible. This is why I went into social science. I was like, I'm not cut out for this. Like, I keep getting fried.
Your mental state makes a lot more sense now.
Yeah. That's where the hair came from too. Anyway, cool. Let's see. Well, I think that is about it. Hey, thanks everybody for listening. It's super fun to do this. And so what I'm going to do now is I'm going to start up the thing and read the credits. And let's hope, would you like to read the credits?
Yes, I'd love to read the credits.
All right, hold on. So because of the audio difficulties we had, this all stays in, Quinn, so everybody can hear just how competent we are.
Okay.
You won't be able to hear but there's going to be some music behind you. You won't be able to hear it, but Quinn will, and hopefully the audience will. But I have to find the music, and so when I say go, then you're going to do it. So are you ready to roll?
I'm so prepared.
Okay, good. Then go.
Teach Me About the Great Lakes is brought to you by the fine people at Illinois Indiana Sea Grant. We encourage you to check out the great work we do at iicgrant.org and at ILIN Sea Grant on Facebook, Twitter, and other social media. Teach Me About the Great Lakes is produced by Hope Charters, Carolyn Foley, Megan Gunn, and Irene Miles. Ethan Chitty is our associate producer and fixer. Our super fun podcast artwork is by Joel Davenport, and the show is edited by Quinn Rose, and I encourage you to check out her work at aspiringrobot.com. If you have a question or comment about the show, please email it to teachmeaboutthegreatlakes@gmail.com or leave a message on our hotline, because we totally have a hotline, at 765-496-IISG. You can also follow the show on Twitter at Teach Great Lakes. Thanks for listening, and keep great in those lakes.